One, welcome to another warm-up. This one, you might notice, is a lovely related to rates problem, so it might take you a couple of minutes. The goal is, of course, that yes, these take you a while at first, but they get faster and faster as you go. So see if you can cruise through this as best you can. At the very least, get as far as you can and then see where you're stuck. But practice making progress. All right, pause the video, give it a try. All right, I'm going to give this a try. I'm going to start off by drawing a picture. So we got two cars driving from the same spot. One is going east. One is going, that's barely a line. One is going north. Okay. It looks like I got Jose going north, and I have Sally going, sorry, not east, but west. You can label these whatever you want, right? You don't have to do J and S. You could do X and Y, but a diagram is definitely nice. And then what we care about is actually their distance. So how far apart are they? Now, if you got confused just getting that far and understanding the problem, well, then you know what part you got stuck on. But maybe pause the video again and keep working if once you get unstuck. Make sure you can get part of this done on your own. The thing that you need to recognize right away is that this shape is a right triangle. Okay, and it looks like let me change this D to something else. Let me change this to a capital D, and you'll see why in a second. It makes my derivatives look prettier. So we were given some stuff. We were given not one but two rates. So it looks like I know that dj dt is equal to 30. And I was also given ds dt, how fast Sally is going, is equal to 45. Now, you might have different letters here, in which case you would have slightly different looking notation, but the numbers should be the same. Okay. We were also have rates that we want. And I encourage you, once you recognize that it's a related rate problem, focus on the rates before you get to anything else. So we want looks like I want this other thing, d capital D dt. dt. We don't know. But we want this at a certain time. So I want it at 2 hours. Or when. You can save yourself a little bit of work later by recognizing that I don't have a good way of plugging in hours into this. What I really want to know is at a certain length. So when it looks like, well, at 2 hours, I can figure out what J is going to be. 2 times 30 is 60. I can figure out what S is going to be. 2 times 45 is equal to 90. And if you have to go back and figure this out later because you're not sure what form you want, fine. Just leave yourself a little blank and know that you probably got to do some work. There's a good chance we might also need to figure out later what D is going to be. And here's where it does help to know your geometry. I'm going to leave that blank for a second. We'll fill it in. Normally, I would have a little spot here for variables, but I think they're pretty clear, right? I think it's pretty clear from the diagram what D is distance. J is how far Jose traveled. So I might forgive you for not including these if the picture is super clear. S is how far Sally traveled. And then, of course, T is time. Okay. Those are my variables. Good to include them, but I think this picture is pretty clear, as long as it's right. If your picture's not right, then it does help to include them. Okay, I need a relationship. To have related rates, I need to have them be related. All right, relationship. So this is usually where geometry comes in. Maybe you see it. I hope you see it at this point. J squared plus S squared is equal to capital D squared, because D is that hypotenuse of that beautiful right triangle. I'm going to implicitly differentiate this. Don't plug in yet. You got to differentiate first. So I get 2j dj dt plus 2s ds dt equals 2d dt dt. All right, using that implicit differentiation with respect to t. Great. So again, if you got stuck before you got this far, maybe pause the video and see if you can finish it up from here. But otherwise, let's keep on going. These get faster as you go. So notice this is only taking me a minute or two. Now I'm at the part where I can start plugging in. And sometimes when I start plugging in, I realize I also need to back solve for a few things. So let's plug in. I know what my j is. This j is going to be a 60 times. I know what my dj dt is, 30. So once we start plugging in, we're focusing on this one moment in time. Plus, I lost my 2 here. Plus 2 times my s at this one moment in time is 90. Times ds dt is 45. Equals 2 times, I don't know what my d is. And I go, oh shoot, I should probably solve for that. And let's go ahead and do a little work here on the side to figure out what this is. Looks like if I have a right triangle and I know that one side is 60 and one is 90, well then this side over here is going to be the square root of 60 squared plus 90 squared. Why? Because 60 squared plus 90 squared is equal to, well, Pythagorean theorem tells me d squared. Okay, so if I solve for d, I get that nice square root. I'm just going to leave it like that, as this big old square root for now. So 2 times the square root of 60 squared plus 90 squared. It simplifies quite a bit, but I like to emphasize that we can leave things if we want to. Great. And now it's just a matter of adding and solving and dividing. I'm going to cheat a little bit, and by cheat I mean I'm going to do algebra. Let's divide everything through by this 2, because I see there's a 2 in every single term. So if I divide both sides by 2, those all go away. And then I can say that dd dt is equal to, well, the left side divided by the right side. So 60 times 30 plus 90 times 45 all over the square root of 60 squared plus 90 squared. You should, in this case, I think, definitely multiply those out, definitely divide them. Because in this case, you're going to get a number out. You know, look at a decimal approximation. See, does it make sense? Am I getting a number that looks like a reasonable speed, considering how fast these people are going? So you can use your own knowledge of the world and geometry to get a real number out. But I'm going to take this opportunity to point out that, like, look, I can do this without a calculator. I can get basically to the end without a calculator by just kind of working my way through and maybe plugging in later. So I'm going to leave it just like that for today. This would have units of miles per hour. All right. I hope that was a good practice. In particular, this was meant to be a practice of, look, I have 3 variables that are all independent, and actually I could just do them on their own because I was given those 2 rates and not just one. Okay, so hopefully that was a good practice as well. I'll see you all in a minute.